I'm Elad. I'm one of the members of the Swarm team. We are actually in full presence here today, so we will be happy to take your questions and help you out. How many developers here in the room? Maybe we can see some hands. Okay. How many people heard of Swarm before? Okay, cool. That's pretty good. Let's get started. So what's Swarm? Basically, it's a peer-to-peer content-addressed storage and delivery network. It's an integral part of the Ethereum Foundation's third web vision. Basically, if Ethereum is considered to be the computer, so we are the hard drive. Basically, we take care of storage and retrieval incentivization as part of actually making sure that the whole infrastructure works. We also have real-time messaging infrastructure, which is built on top of Swarm using Whisper, encapsulated with Whisper. And as part of our design, we are censorship and DDoS resistant, and also fault tolerant by using erasure coding and redundancy, which is built into the network. So let's go over a few basic notions of Swarm. For the ones of you who don't know. So we basically have chunks, hashes, and manifests. These are our basic data structures or units of accounting which we will treat. So chunks basically is our most basic data type. Everything on Swarm basically translates into chunks. They are 4 kilobyte in size each. And they hold arbitrary data as well as other Swarm primitives, such as, for example, Swarm feed, root chunks, and so on. They have redundancy over the network, so once you sync a chunk over Swarm, it's basically supposed to be stored on the network in three different nodes. And they reside in the closest proximity to the participating nodes' addresses. Hashes. So our chunks are basically the chunk hashes are BMT hashes, which are binary Merkle tree hashes. And hashes are a Merkle tree representation with SHA. It's a SHA-3 Keccak-256 hash, basically, that represents, it's a content-addressed hash, which represents the data that you've just uploaded to Swarm. They are collision-free, and they also facilitate proof of custody further down the road. Everybody's following me so far. Are there any questions so far? Okay, cool. So we have also manifests, which are one of the more visible parts of Swarm, which you would probably interact with. They are basically collections. You can think about them as a mapping between strings, arbitrary paths, and actually Swarm hashes of content. So once you upload a file to Swarm, the arbitrary data would have its own hash, and then a manifest which holds metadata over the files. So like MIME types, size, and so on, which facilitate actually the proper display in a browser, for example. That would be included in a manifest and uploaded alongside with the file itself to Swarm. So basically you would, for the most of the times, you would be accessing data through manifests. So we also specify MIME types over Swarm, so browsers know how to present and display the data or download it in case it's necessary. And tries are the manifests are represented as compacted tries, which also guarantees basically logarithmic search complexity when looking for files in very big directories. The APIs also are exposed through the HTTP and CLI. We'll get to that. So basically, when you upload a directory to Swarm, this is one of the ways to do so. So you specify an endpoint which you can upload to a node's endpoint, basically, and a directory, let's say, or a file that you would like to upload to Swarm. And so once you do that, what you get in return is a hash. That hash is a content addressed hash. It won't change if you re-upload the same file, and you can access your content according to this hash. One of also the beautiful things about this, to kind of hook things up with what Makoto talked about before, is that you can actually use Swarm hashes with ENS. So I will show you in a bit also that you can actually use Swarm hashes when you set them in the resolver smart contract and with your ENS name, and then you can actually access a website. You don't need to remember these hashes. It's a bit unpractical. So this is how a manifest actually looks like. If you upload a file or a directory, and then you would actually use an address with the BZZ raw scheme. I'll show you in a bit also different ways to do the tips and tricks with our different schemes. So you basically get a JSON. Manifest is essentially a JSON, and as you can see, it maps hashes to file names and MIME types. Pretty simple. We also support encryption and access control. This is something that was added to Swarm in the last 4 months, let's say, intensively. So we use counter mode encryption. And we have, about a month and a half ago, merged access control into Swarm. What this basically means is that you can upload content to Swarm and basically selectively disclose it to certain parties. So if I have my own private key and I would like to disclose a certain piece of content to someone whom I know his public or hers public key, I could just grant them access to this piece of content and distribute this hash basically publicly, because nobody will know how to decrypt the reference to the actual content which is encapsulated in this manifest. And basically nobody can also know the identities of the disclosed parties. It's very important. You can also disclose, you can do selective disclosure using passwords and elliptic curve keys. Yeah, and the APIs are also exposed through CLI and HTTP. Yeah, so this is a big thing for us for the last few months, and we would be happy to guide you through doing this. So basically, this is just for the encryption. Usually, when you upload encrypted content to Swarm, so you would be able to know that it is encrypted by the double length hashes, which are basically a concatenation of a normal Swarm hash and the decryption key for the content. Since we are using counter mode encryption, basically means that even if you want to disclose a certain part of a file or a certain part of a manifest, let's say, which was encrypted, you don't necessarily need to disclose the encryption key for the whole content, but you can disclose just a certain part of the content without disclosing the encryption keys for the decryption keys for the entire content. Okay, Swarm feeds are also something that was completely re-engineered and rewritten in the last few months, and are a very strong point that we're working on right now. So basically, because we are dealing with content addressed hashes, so this means we will basically, for the most of it, we'll have to deal with ever-changing hashes. So let's say that you would like to update your website, so the hash will constantly change once static content changes on the website, not to mention what happens when we're talking about user-generated content. So Swarm feeds to the rescue. Basically, they provide a predictable way of updating resources that you upload. So let's say you uploaded your website, and it is, once you change it, if you do so through a Swarm feed, you don't really need to update your ENS resolver address. So your ENS resolver points to the Swarm feed address, and that will automatically resolve the latest version that you have just pushed to Swarm. Yeah, so this basically reduces the dependency on the ENS. I hope Makoto is not insulted. Yeah, because ENS updates, they cost money, and they take time, and you are at the mercy of miners in the end of the day. So basically, Swarm feeds come to resolve this problem. We also support multi-hash updates. So basically, you could upload a certain content to Swarm, get the hash that was generated out of it, make a multi-hash out of it, and anybody doesn't know what multi-hashes are? I don't know. So basically, it's hashes which are it's basically self-describing hashes. So as part of the hash, you also get the type of the hash, which it's kind of a prefix to
it's called multi-hash. Sounds like there's a bunch of hashes.
Yeah, because it's basically it's a kind of a system to describe different types of hashes through a mechanism which is self-describing. So basically, you get, for example, for SHA-3 hashes, you get a certain, I think it's 0, 1, B something, which is prefixed to the hash, and then you know that it's a SHA-3 Kachak-256 hash. Yeah, so basically you can submit resource updates with multi-hashes. Yeah, so basically also the creation and updates of Swarm feeds are signed by the resource owner, the publisher. So basically, nobody can actually use your Swarm feed to submit updates or hijack your website. So it is, you have to possess the private key and sign the actual update so that the network accepts this update and displays it, resolves it for users. Another way to actually kind of describe maybe Swarm feeds would be to think about it as, this is actually in the next slide. So we have a topic basically and a user. That's what a Swarm feed is in the end of the day. So a topic could be a 32-byte arbitrary string, and the user is actually the Ethereum address. So basically, you could think about this as a mechanism to basically aggregate. Let's say I want to create a Swarm feed with all of my posts or all of my image updates, my Instagram, whatever updates, or Twitter updates. So you could actually create, a user could create a Swarm feed of topic, I don't know, my emotions, and basically submit updates to this Swarm feed. Everybody could actually, knowing the user's Ethereum address, could actually query and get all of the updates, the previous updates that the user has posted to the Swarm feed, which is kind of, I think, very interesting and a breakthrough in a sense of how do we treat data streams and feeds from users in a decentralized manner. So, question.
Can you set the ENS name as a user?
I think so. Victor, can we set a user as an ENS name as a user? You need an address.
The user has to be an address.
Yeah.
Because the point he feeds is that as a chunk, and the thing is captured as a chunk, it has to be validated by any new other information. It means that the signed content of a feed is used with EC recovers to pop the address from it, and the address is matched to the actual hash address. So it has to be an address there. Is definitely. I mean, you can have the topic as an ENS address, which means that you make some feed relating to a particular address, or you can actually have arbitrary feed topics registered under your ENS, which means that you can go to, I don't know, david.eth/cv, and your CV is always the up-to-date version because it contains a reference to a Swarm feed, and the Swarm automatically resolves that to the latest version. Yeah. So which means that ENS you need to use only once when you create the updatable feed, and you don't need to pay transaction costs.
All right. So, yeah, a little bit more about what we have as infrastructure. We have PSS also, which is basically BZZ whispered, bzz. So we have bzz and sh. It's ps. And it basically facilitates node-to-node messaging over Swarm using Whisper. And we do not offer any mailboxing at the moment. And you can try to use it through the Erebus JavaScript library. There's references to all of this in the end of the slide deck. So basically, if you know a node's address, you could send a message directly to that node. PSS also, basically, the nice thing about it is that it provides also a sliding scale of stealth, let's say, message delivery. So maybe you would like to send a message to just a certain to appear that you know its address, but you don't want that the forwarders of the messages to know who you're sending the message to. So we basically provide a kind of a sliding scale to possibilities to deliver messages. It's kind of like broadcasting, that you could actually broadcast to a range of addresses. You would actually have to pay for the transmission of the messages also, but it provides a sliding scale in terms of privacy and over performance, of course, and cost efficiency. Yeah, so basically you can see our website on Swarm Gateways, which actually the website is hosted on Swarm. The QR code would lead you there. We are available to support you on Gitter. You can basically just ping us on the Orange Lounge room, and we would gladly help you with anything. We will be here also to help you out. The guide is a very comprehensive source of information for you all to dig into, and we would be happy to assist you with any concern or question. Yeah, so that's about it, I guess.
Thank you so much.